Welcome students. I, Preeti Sinhal, an assistant professor at AISSMS College of Hotel Management and Catering Technology, Pune. In today's session, we are going to learn microbes in biogas. It's an energy production. So let's start with that. The objective of this chapter are to learn about what is microbes, to learn about biogas, to learn use of microbes in biogas production. Have you ever wondered where our energy comes from and how we can make it cleaner and more sustainable? Today, we are delving into the fascinating world of biogas production and the remarkable role that microorganisms play in this renewable energy source. Let's join me as we explore how these tiny organisms are turning organic waste into clean, sustainable energy. So let's walk into it. Let's first understand what is biogas production. So biogas isn't just an energy source, it's special because it's renewable and clean. And guess what? It's made by something as simple as microorganisms breaking down organic matter. It's like nature's own power plant. Biogas is a renewable energy source produced through the anaerobic digestion of organic matter. This process involves the breakdown of organic material by microorganisms in the absence of oxygen, resulting in the production of biogas, a mixture of methane and carbon dioxide. So biogas is a mixture of gases which is containing predominantly methane, produced by the microbial activity and which may be used as fuel. Microbes produce different types of gaseous end products during growth and metabolism. The type of the gas produced depends upon the microbes and the organic substrates they utilize. However, certain bacteria which grow anaerobically on cellulosic material produce large amount of methane along with CO2 and H2. These bacteria are collectively called methanogens. These bacteria also known as methanobacterium. What is the importance of biogas? So biogas holds immense importance as a renewable energy source due to its versatility and environmental benefits. It can be used for electricity generation, heating and cooking, reducing reliance on fossil fuels and mitigating greenhouse gas emissions. Biogas is a big deal for our planet. It's not just making energy, it's about doing it in a way that's kinder to the environment. By using biogas, we can reduce our reliance on fossil fuels and cut down on harmful greenhouse gas emissions. Now, let's understand what is the role of microorganism in biogas production. Let's talk about the real heroes of biogas production. Microorganisms. These tiny creatures are the ones responsible for turning our waste into something useful. They work tirelessly behind the scenes to break down organic matter and create biogas. Microorganisms are the driving force behind biogas production, performing key functions in the anaerobic digestion process. They break down complex organic compounds into simpler molecules, releasing biogas as a byproduct. Now there are different types of processes. Let's understand some of the processes. Anaerobic digestion process. So imagine a big party happening underground where microorganisms are breaking down food scraps, animal wastes and other organic materials. It's called anaerobic digestion, and it's where the magic of biogas production happens. Anaerobic digestion is like a microbial feast where organic matter serves as the main course. In the absence of oxygen, microorganisms break down carbohydrates, proteins and fats into methane, carbon dioxide and other gases. Types of microorganisms in anaerobic digestion. So in this microbial party, there are different types of guests with unique roles to play, from bacteria to archaea. Each one has a job to do in breaking down the organic matter and producing biogas. The anaerobic digestion process relies on a diverse community of microorganisms, including bacteria, archaea and fungi. Each group has its own role in the breakdown of organic matter and the production of biogas. Let's understand. Let's go slowly ahead. What we have done till now, what are the importance, types of microorganism, methanogens bacteria, we have understood anaerobic digestion process. Now let's move to methanogens bacteria. Methanogenic bacteria are like the chefs of the party, cooking up methane, the main ingredient in biogas. They thrive in the oxygen-free environment of anaerobic digestion and play a crucial role in producing clean and renewable energy. Methanogens bacteria are the stars of the show in anaerobic digestion, producing methane through a process called methanogenesis. They thrive in oxygen-deprived environments and play a crucial role in biogas production. Acidogenic bacteria. We have understood methanogenic bacteria. Now let's understand the other types of bacteria. So acidogenic bacteria are the ones who get the party started, like in starter, by breaking down complex organic compounds into simpler molecules. They are like the cleanup crew, preparing the organic matter for the methanogenic bacteria to turn into biogas. Acidogenic bacteria are specialists in converting organic acids and alcohol into acetate, a precursor for methane production. They help optimize the efficiency of anaerobic digestion by maximizing the conversion of substrates into biogas. Now next, another type of bacteria, syntrophic bacteria. Syntrophic bacteria are the team player that engage in mutualistic relationships with methanogenic archaea. They degrade complex organic compounds into simpler molecules, providing methanogens with substrates of methane production. Syntrophic bacteria are working together with methanogenic archaea to break down tough organic compounds. They are like the best friends who always have each other's back, ensuring that nothing goes to waste. So these are some of the different types of bacteria. We have learned about methanogenic bacteria, we have learned about acidogenic bacteria and syntrophic bacteria. So these are different bacteria which plays their own roles. So now archaea, what does they do in anaerobic digestion? So methanogenic archaea are the rock star of the party, producing methane like nobody's business. Methanogenic archaea are the methane producing champions of anaerobic digestion. They thrive in extreme environment and play a vital role in converting carbon-rich substances into methane, a valuable energy source. Let's understand now the fermentation phase which happens during the biogas production. So picture a bustling kitchen where microorganisms are busy breaking down complex organic compounds into simpler molecules. It's like a cooking marathon where every bit of waste gets transformed into something useful. The fermentation phase of anaerobic digestion, it's like the opening act of a grand performance. During this stage, complex organic compounds are broken down into volatile fatty acids, alcohols, and other intermediates by fermentive microorganisms. Under that, there is a hydrolysis phase also. So what is hydrolysis phase? It is the first step in the breakdown of complex organic matter, where large molecules such as carbohydrate, proteins, and fats are enzymatically converted into simpler compounds by hydrolytic microorganisms. Acidogenesis phase. Now earlier we understood hydrolysis phase. Now next phase is acidogenesis phase, where the action heats up as acidogenic bacteria take center stage. They ferment the intermediate products of hydrolysis, producing volatile fatty acids, alcohol, and organic acids as byproducts. Acidogenesis is like the bridge between acidogenesis and methanogenesis, where acidogenic bacteria convert organic acids and alcohol into acetate, a key precursor for methane production by methanogenetic archaea. Now we have understood these two phases. The next is methanogenesis phase. It is the grand finale of the anaerobic digestion, where methanogenic bacteria and archaea work their magic to produce methane from acetate, hydrogen, and carbon dioxide. This methane-rich biogas is captured and utilized as a renewable energy source. Now we have done the fermentation. Now definitely there are factors which affect the biogas production. So there are several factors influence the efficiency and performance of biogas production system. Some are substrate composition and quality. The composition of the organic substrate significantly impacts biogas production. Substrates rich in carbohydrates, proteins, and fats are more easily digestible by microorganisms, leading to higher methane yields. Second point is temperature and pH. That plays a very crucial role, and that affects the biogas production at a major level. As we understood that temperature and pH play critical role in maintaining optimal condition for microbial activity in anaerobic digestion. Mesophilic and thermophilic temperatures, along with neutral to slightly acidic pH levels, promote efficient biogas production. Next is hydraulic retention time. So hydraulic retention time, which is also known as HRT, refers to the duration that organic matter remains in the digester. Longer HRTs allow for more thorough digestion of substrates, resulting in higher biogas yields and greater process stability. Now let's one more point where microbial diversity and activity that also affect the overall biogas production. So it is essential for maintaining robust anaerobic digestion processes. A diverse microbial community ensures redundancy and resilience, enabling efficient substrate degradation and biogas production under varying conditions. Now the production has happened, we have learned about how the fermentation happens, what are the factors which affect the production. Let's understand what are the utilization of the biogas. So first and foremost is electricity generation. Biogas can be utilized in combined heat and power system. It is also known as CHP, combined heat and power system, to generate electricity and heat simultaneously. This renewable energy source can help offset fossil fuel consumption and reduce greenhouse gas emissions. Next is heating and cooking. For that also biogas can be utilized. So biogas is a clean and efficient fuel for heating and cooking in residential, commercial and industrial setting. It provides a renewable alternative to fossil fuels, reducing reliance on non-renewable sources and mitigating environmental impact. With all this, I will conclude this, and let's have a little recap that what we have learned under this session. So we have learned about the biogas production. What is biogas? We have learned that biogas isn't just any energy source. It's special because it is renewable and clean. Then we have understood that what biogas is a mixture of gases, right, which produced by the microbial activity and which may be used as a fuel. Then we understood that importance of biogas. Biogas holds immense importance because it's a renewable energy source due to its versatility and environmental benefit, which is saving us from the greenhouse effect, which is very, very important for the planet. It also cut down on harmful gas emission, fossil fuels it is reducing. That is why it is very, very important. Then we understood, or we learned, role of microorganism in that, how microorganisms are the driving force behind biogas production. We have learned about different processes. Under that, anaerobic digestion process we have learned, where microorganisms are breaking down food scraps and animal waste and other organic materials. It's called anaerobic digestion, and it's where the magic of biogas production happens. Then we have learned about types of microorganisms in anaerobic digestion. In that, methanogenic bacteria we have learned about. We have learned about acidogenic bacteria and syntrophic bacteria. These are the different bacteria which plays a very, very important role into it. Then after we have learnt about archaea in anaerobic digestion, that is also we have learnt. We have learnt about the fermentation phase during the biogas production. In that, how the anaerobic digestion happens and complex organic compounds are broken down into volatile fatty acids, alcohol and other intermediates by fermentative of microorganisms. Then we understood hydrolysis phase, acidogenesis phase, then methogenesis phase. These are different phases we have learned into it. We have moved after that to factor affecting biogas production. Into that, substrate composition and quality, temperature and pH, and hydraulic retention time with microbial diversity and activity. These are some of the points which affects biogas production. Utilization we have understood. Into that, electricity generation and how it has been used for heating and cooking. Thank you.